Assalamualaikum and salam sejahtera. So for today's lesson, we are going to learn chapter 1, which is quadratic functions and equation in one variables. So for our first chapter, the first lesson that you need to know is what is a quadratic expressions in one variable. So quadratic expressions in one variable can be identified by these two characteristics, which is the first one. The quadratic expression, the highest power of the variable must be 2, and then the power of the variable must be a whole number. It means that you cannot, the power of the variable cannot have a point or decimal or fraction. And then look at the example. This is the example of the quadratic expression in one variable, which is x squared plus 2x minus 1. Okay, look at here. This is the highest power of the variable is 2. So this is what we call as the highest power of the variable must be 2. So it must be 2 and it must be a whole number and it cannot be a decimal or fraction. Okay, this is the example of the quadratic expression in one variable. Okay, now look at example 2. X plus 2x squared minus 6x cube plus 10. Okay, there the unknown is x, right? So this is the power here is 1 and then the power here is 2 and then the power here is 3. Okay, we recall back the first characteristic of the quadratic expression is the highest power of the variable must be 2. So this one, the highest power is 3. That's why this is not a quadratic expression. Okay, clear? Okay, now look at the second characteristic. The general form of a quadratic expression is ax squared plus bx plus c, where a, b, and c are constant. What does it mean by constant? Constant means it has a value, a number, which is 1, 2, 3 or something like that, or it can be 1/2, it can be in fraction, and it also can be in decimal. Okay, now look at the second one. A is must not equal to 0 and B and C can be 0. Only the value of A here cannot be 0. B and C, it can be 0. Okay, now look at the third one. X is a variable. The variable can only have one. X can be anything. It can be Y, Z, A, B, C or anything. As long as the variable in this expression just one only. Okay, so that's it. Okay, now we continue with the example of example 1. Okay, now if the question asks you to determine whether each of the following expressions is a quadratic expression in one variable. If not, justify your answer. Okay, now look at A. A is 2x squared plus 5. Okay, now is it satisfy the first characteristic, which is the highest power of the variable must be 2. So the highest power of the variable is 2, then correct for the first characteristic. Now for the second characteristic, the general form of a quadratic expression is ax squared plus bx plus c. Okay, now look at the question. A, 2x squared plus 5. A is, okay, for this characteristic, A must be not equal to 0. So then this one is correct lah, because the value of A is 2. Now, B and C can be 0. Okay, correct. B, where is the value of B? It's supposed to be in the forms of like this, 2x plus bx plus c. And then the question gives you the expression like this, 2x squared plus 5. So where is the value of B? This is the value for C, this is the value for A. It means that if B doesn't have in the expression, means that B is 0. So if B is 0, can we consider this expression as a quadratic expression in one variable? Then yes, this is the quadratic expression in one variable, because B here, I already told you that B and C can be 0. Okay, so it means that A which is 2x squared plus 5 is a quadratic expression in one variable. Okay, now done for this one. Okay, now for B. B is x cubed minus 6. Okay, now is it this expression is a quadratic expression in one variable? The answer is not, because okay, look at the highest power. The highest power is 3. So automatically it doesn't satisfy the first characteristic. So means that this is not a quadratic expression in one variable. Okay. Now C. 3x squared plus 2y plus 1. Okay. 3x squared plus 2y plus 1. Okay, now the highest power is 2, correct? And then the general form is ax squared plus bx plus c. Okay, now the second characteristic is not satisfied because of what? Because the value of the unknown is more than 1. Okay, look at this the second characteristic. X is a variable. The variable can only have one, but this question have more than one variable. So this is not a quadratic expression in one variable because the variable have more than one. That is the reason. Okay, now look at D. D is 1 over 2 m squared. M squared. Remember the variable I told you? The variable can be x, can be y, can be m or anything as long as it only have one only. Okay, now D, 1 over 2 m squared. Okay, 1 over 2 m squared. Is it satisfy the first characteristic, which is the highest power is 2? Then yes, correct. Now look at the second characteristic. Is it correct, which is A must be not equal to 0. So for this question, the A is 1 over 2, then correct. And then there is no value of B and C. Why? Why it doesn't have the value of B and C? So it means that the value for this quadratic expression is 0, which is B and C. So that's why it doesn't state here. Okay, now. Okay, so it means that it satisfies the second characteristic also. So it means that this is a quadratic expression in one variable. Okay, now look at E. E, 2x squared minus 3 over x squared. Okay, is it satisfy the first characteristic? Okay, look at here. 3x squared plus 2x squared minus 3 over x squared. Okay, now look at the problem is here. The unknown is in denominator. So if you bring it to bawa ke atas, awak akan dapat 2x squared minus 3x squared, bring it to the upright, then x negative 2. Okay, so it means that the highest power is 2, correct? But this is the another power which is negative 2. So I told you before this. Okay, if the power is negative 2, means that it is not in the forms of positive number, then this one is not a quadratic expression in one variable. Okay, remember that one? Okay, so automatically we know that this is not a quadratic expression in one variable. Okay, now look at F, our last example. 4x squared minus x 1 over 2. Okay, 4x squared minus x 1 over 2. So this is, I already told you, for the first characteristic of the quadratic expression in one variable. The highest power is 2, and then the power of the variable must be a whole number. But this one, there is a fraction. The power is in the forms of fraction. So it means that this is not a quadratic expression in one variable. Because of what? Because there is a variable with a power which is not a whole number, like that. Okay? Okay, now we continue our second lesson. Okay, what is the quadratic function? Okay, just now we learned what is quadratic expression, but our second lesson is you need to know what is the quadratic functions and its relationship between many to one relation. Okay, now this is the different thing. Okay, this is quadratic expression, this is quadratic function. Okay, now look at what is the quadratic functions. Okay, quadratic function, the general forms of a quadratic function is f of x is equal to ax squared plus bx plus c. Okay, different from the quadratic expression. It just have ax squared plus bx plus c. It doesn't have equality or it doesn't have fx. But for quadratic function, it must have f of x here. F of x is equal to ax squared plus bx plus c. Okay, now that is the first one. Now the second one, all the quadratic function have the same image. All the quadratic function have the same image for two different objects. It means that for two different objects, okay, wait. Okay, for two different objects, okay, this is object, okay, this is image. Okay, now for two different objects, for example, like the object is like this, 2, 3, and then the image, okay, for the two object here, it must have the same image. It must have the same image. So this is the definition. What does it mean by the same image for two different objects? Okay, if you still remember you already learned about relation, right? Relation, many to one, one to many. There is 4 types of relation, but for this one, for quadratic function, one of the characteristic of the quadratic function is it have the same image for two different objects. Same image for two different objects. So it means that we can conclude that the types of relation of a quadratic function is a many to one relation. So that is the relationship between quadratic function and many to one relation. Okay? Okay, class, we continue lesson number 3. Okay, what is the shape of a quadratic function? Okay, as for your information, quadratic function can be represented in the forms of graph. Okay, how the graph is? Macam mana bentuk graph tersebut? Okay, now, what is the shape of a quadratic function? Okay, the first one, the quadratic function only have two shapes of graph, two types of shape of graph for quadratic functions. Remember that one? Okay, and then the value of a determine the shape of a graph. Okay, remember the general form of a quadratic function, which is fx, wait. Okay, quadratic function. Quadratic function, the general form is fx equal to ax squared plus bx plus c. Okay, now, the value of a determine the shape of the graph. What does it mean, the value of a? The value of a here. Okay, for example, like if the question give you the quadratic function like this, okay, 2x squared plus 3x plus 4. Okay, now, okay, look at C first. Okay, see, if A is greater than 0, means that if A is the positive number, then the graph is like this, which is the smiley graph. But kalau if the value of A is a negative value, then the graph is like this, masam, graph masam. This one graph senyum. Okay, ingat the two different thing of graph. Remember, quadratic function have only two shapes of graph. If the value of a is positive, which is greater than 0, it means that the graph is smiley. But if the value of a is negative or less than 0, it means that the graph is masam lah, graph masam. Okay, now look at the quadratic function I write here. Okay, fx is equal to 2x squared plus 3x plus 4. Okay, if the question give you this quadratic function and the question asks you to determine the shape of the graph, okay, what should you do? Okay, you should look at the value of a here. Okay, the value of a here is 2. 2 means it's greater than 0. So if the value of a is greater than 0, so the graph is smiley, like that. Okay, so graph smiley. Okay, and if the value of a is negative, then the graph is masam lah, graph masam. Boleh Okay, we continue lesson number 4. What is maximum or minimum point of a quadratic function? Okay, remember the shapes of a graph for a quadratic function. There is two types of shapes of the graph, right? So for a is greater than 0, so the graph is senyum, and then for a is less than 0, so the graph is masam. Okay, now where is the positions of the maximum or minimum point? Okay, look at here. Okay, for the graph, for a is greater than 0, we know that the graph is smiley like this, right? So, if the graph is smiley, the only point is minimum point. The minimum point was in here. Okay, this is what we call as a minimum point, x2, y2, at the coordinate of x2, y2. So, this is for minimum point. So, it means that for a smiley graph, it will only have a minimum point, which is in here. Okay, now look at the other graph. A is less than 0, so that means that the graph is masam, graph masam. So kalau if the graph is masam, so it means that this is the point that we call as a maximum point, which is x1, y1. This is the maximum point. So remember, for a is greater than 0, then it will have a minimum point. And then for a is less than 0, it will have a maximum point. That's it. That is the thing that you need to remember. Okay, now look at lesson number 5. What is the axis of symmetry of the graph of a quadratic function? So this one is the things that you need to know. Axis of symmetry, what is it? Okay, now look at the characteristic of the axis of symmetry. It have 3 characteristics. Okay, now the first one, axis of symmetry is a straight line that is parallel to the y-axis. This is axis of symmetry, and then this is also the axis of symmetry, which means it is parallel to the y-axis. Okay, now the second one, axis of symmetry divides the graph into 2 parts of the same size and shape. So remember, the axis of symmetry will divide the graph into 2 equal parts. Okay, like this one. Okay, now the third one, axis of symmetry will pass through the maximum or minimum point of the graph. As you can see, this is axis of symmetry. For a is less than 0. For a is less than 0, the axis of symmetry will cut the graph on the maximum point. And then for the graph a is greater than 0, which is smiley one, the axis of symmetry will cut the graph and passes through the minimum point. This is the dotted line here is axis of symmetry. And then for this one, the equation of the axis of symmetry is x is equal to m. Why is equal to m? Because the axis of symmetry cut the x-axis. This is what this is the coordinate of m. So axis of symmetry, it will cut the x-axis part. So that's why we will take the m only. So x is equal to m. Okay, same goes as for this one also, which is x is equal to h. H was in the coordinate of the x-axis. Okay, it's okay. I will give you example for this one. Okay, look at here. Okay, this is example for a is greater than 0, which is the graph is smiley. Okay, now if the minimum point given to you 2, 3, the minimum point, the coordinate is 2, 3, then this is the axis of symmetry, and then the equation of the axis of symmetry will be x is equal to 2. You need to take the x coordinate for the minimum point, which is x is equal to 2. Now for b, this is the graph a is less than 0, so the graph will be masam. So untuk graph masam macam ni, so the axis of symmetry, it will cut the maximum point here. This is the dotted line we call as axis of symmetry. Okay, for the axis of symmetry here, the equation is x is equal to 6. This is the equation of axis of symmetry. That's it. Itu sahaja. Okay, class, we continue with some other example. Okay, let's say this is the graph, and then the question asks you to find the equation of the axis of symmetry. Okay, now this is the only thing that given. Okay, now 5 with 2. Okay, we know this is the minimum point, right? So we know the axis of symmetry, x is equal to, look at this one, minimum point. For the minimum point here for the x-axis is in here, right? So what is the coordinate of here, which is 3.5. So for the x-axis, the equation is x is equal to 3.5, like this. Okay, now